Hi, good afternoon. This is Mr. Cassidy, and today we're going to do our overall Chapter 2 review. A little bit of review of that last lesson, 2.5, with a few weird problems. And we're putting it all together. Just for our heads up, for our agenda this week, we have a chapter review of the whole chapter coming Tuesday, and then Thursday will be our Chapter 2 test. All right, well, let's get started. So we started our class with one-step equations, and I want you guys to go and start by solving this one. So you should have gotten x equals -4, and how you got that was by adding 8 to both sides. Great. How about let's go over to the right here and solve for x here. You should have gotten x equals -19. All right, how about the next problem to the left? Go ahead. You should have divided by 5 on both sides. And when you punch that into a calculator, you get x equals -8. And how about this problem to the right here? Well, you should have multiplied by 10 because x is being divided by 10. And that would give you that x equals -20. Okay, next, what do we do when we see a fraction with x? Go ahead and try it out. So you should have flipped over the fraction and multiplied both sides. That's our trick here. When we multiply by 7 over 3 on both sides, notice that that cancels out entirely with the x. And on the right-hand side, we can reduce the 3's. 3 divided by 3 is 1. And 28 divided by 7 leaves us with 4 here. So x is equal to 1/4. All right, and what do we do with the decimal in front of x? Since 0.7 is multiplied by x, we divide by 0.7. And those would cancel out, and x is going to be equal to 8. All right, so that covers our first lesson. Hopefully that's a little review that'll help you guys out. And guys, just as an example, with the second problem here, let me put a box around it. At the end of your problems, you can always check your answers. And while I don't do this all the time with algebra, I do find it's helpful during a test to check my answer. And what I'm going to do is put -19. I'm going to substitute it for x in the original problem. So that means I put -19 where the x is and write the problem. -19 plus 14 equals -5. And what I want to do is check to make sure that I get the same thing as the answer. So I do -19 plus 14, that is -5. And does that equal -5? Yes, it does. So check. That check mark to me means, yes, I got this one right. Okay. Our second idea was two-step equations. Here you've got 2 to solve. Go and start with the one on the left. All right. You should have added 13 first and gotten that 5x, bring down whatever's left here. 5x equals 35, and then divided by 5 to get x equal 7. Okay, go and solve the second one here. It's a little bit trickier. Okay, you should have started by taking this +9 and undoing that, because remember, we want to work outside in. X is with the 2 here. The 9 is furthest away, so we subtract 9 from both sides. And bring down whatever's left. Keep the minus sign with the x. I can't say it often enough. That is one of the most common mistakes, is people leave out the negative sign when they rewrite the problem. We subtract 9 from 17 and get 8. And here I would divide by -2, since -2 is multiplying by x. And now I've got a positive divide by negative, so x is equal to a -4. All right, let's go and practice lesson 3 is on word problems. So first, let's start by writing an equation for this one. Pick the right one in the multiple choice. So remember, the way we start this is by brainstorming it above. And we go 8 here, less usually means subtraction, and than's our flip word. That means switch whatever comes next with the -8. 3 times a number, well, 3 times a number is going to be 3n, or 3x, however you want to write it, is 22, equals 22. And so we need to do that flip-flop and get 3n minus 8 equals 22. Remember, than means switch the operations around. All right, our second kind of problem might be a word problem that has us write the equation. Remember, we always want to set it up with a one-time amount. There's always a one-time thing plus the each or the per thing, and that's going to go with our x, equals total. Okay, so almost all word problems follow the same formula, and we just need to find out which one is which. So start by read the word problem to yourself and pick the formula that matches. Okay, you should have picked that he bought the watch for $83. Must have been a nice watch, but maybe not an Apple Watch. And apparently he's still into fidget spinners, so he bought $5 each there, so it's going to be adding $5 per fidget spinner. X is going to be our number of fidget spinners, and the total is 113. Then to solve, we would subtract, go ahead and solve. How many fidget spinners did he buy? Well, you should have subtracted 83 from both sides, because that's our outside in number, and we get 5x equals, let's see here, 30. And then we're going to divide by 5 and get our answer. X is equal to 6 fidget spinners. All right. Our next idea that we covered last week was really equations with the variable on both sides. Go ahead and practice. Let's do this one step by step together. So first, move the smaller variable to the other side. And you should have moved the 4x to the other side. The trick is, remember, if you move it over, that makes it minus 4x on the right. We bring down what's left and we get negative 60 here equals 8x minus 4x is 4x plus 12. All right, go and solve from there. You should have subtracted 12 from each side and gotten negative 72 equals 4x and divided that by 4 to get, let's see here, maybe, I believe x equals negative 18. I could be wrong, I don't have a calculator in front of me, so let's leave it with that. And if I need to correct it on my video or problems, I will. All right, so try to repeat those same steps with problem 2 here. That 12 is part of the problem here. Okay, you should have started by moving the smaller x over. It's the minus 2x. When we move it over, it becomes a plus 2x. And that's gone now. So I get 12 equals negative 18. And I'm going to go ahead and combine the like terms here, plus 3x plus 2x to plus 5x. And from there, I'd continue solving by adding the 18 and getting 30 equals 5x. Divide by 5 to get x equals 6. Awesome. All right. Now we get to the big tough ones. We're just going to do 2, but I'm going to help you step by step. So with the first problem here, go ahead and distribute the 3 and pick the answer for what you get on the left-hand side of the equation. So remember, when we distribute, we want to circle each thing with its sign if needed, and draw the arrows. And so you should have done 3 times 4x and 3 times minus 8, and gotten that that was a 12x and a minus 24, and then we smush those back together. 12x minus 24 equals 2x plus 6. And now this looks like what we were doing on the previous slide. Go ahead and move the x to the left-hand side. So you should have moved 2x over, and how do we get rid of a positive 2x? The other way of doing this is writing minus 2x on each side. But it's the same as the trick, because it just removes the x and brings it over to this side, changing its sign. 12x minus 2 is 10x minus 24 equals 6. Go ahead and move the whole number to the other side. So you should have moved the minus 24 over by making it plus 24. And that gets rid of it here, and we have 10x equals now 30. Solve for x now. You should have gotten that x equals 3. Now we should be able to check. We can go back, and again, if this were the test, I would put it here and put it here and see if this works. Okay, next problem. 17 is part of the problem here. Don't leave out that 17. Start by distributing on the left-hand side. Pick the one that distributes correctly. Okay, so you should have distributed the minus 3 to the x and the plus 1. I'm just going to write that separately. Minus 3 times x and minus 3 times plus 1. And that means that's a minus 3x, and a negative 3 times 1 is negative 3. So when you distribute that, you should have gotten that and filled in the other numbers around it. 17 minus 3x minus 3 plus 2x equals 6x. Okay, if you didn't get there, this is your chance to come back into the fold. Let's combine the like terms here on the left-hand side. So you should have combined the minus 3x and the plus 2x to get negative 3 plus 2 is a negative 1x. You should have also combined the 17 and the minus 3. 17 minus 3 is 14 equals 6x. All right, we're getting there. Next, we've already got our whole number here. Let's move the 1x over to the other side. So what do you get in your next step? You should have 14 equals 7x, because the 1x here goes over and becomes plus 1x. And go ahead and solve for x. You should have divided by 7 and gotten x equals 2. Now I helped you step by step on this. Tomorrow I'm going to give you some ones that you're going to try all the way through, just 2 or 3 problems like this to try the big giant ones. Again, this brought us to our last idea of the chapter, the weird ones. A quick review. So we have a few situations that are just strange. Let's start by talking about the common scenario. The common scenario is a one solution scenario. Now, let me change this to maybe black. One solution is always going to work when you have a different amount of the variable on each side. So see in my example here I've got a scale with 2x plus 1 on the left and x plus 3 on the right. Because the x amount is different, I know that that's going to have just one solution. No matter what, there will be an answer for that problem. So here are some examples. 2x plus 1 equals 3x, because 2x and 3x are different amounts of x on each side. Here's another example. 5x minus 10 equals 25. Well, notice the other side doesn't even have x. There isn't one. So yeah, that's a different amount of x's. This side has it, this side doesn't. So that is a different amount of the variable on each side. So it's one solution. I would take a screenshot of this or go and copy it in your notes. Our second idea is infinite solutions. Well, infinite solutions are when we have the same amount of the variable and the constant on each side. The sides are identical. So here's what that looks like. Here I've got x plus 1 equals x plus 1. Because here, if you think about it, if you start putting numbers in for x, well, that x could be 5, right? So 5 plus 1 equals 5 plus 1. That works. We get 6 on both sides. But x could also be 10, right? Okay, x is 10. 10 plus 1 equals 10 plus 1. That works too. Notice we can't figure out what x is because it's exactly identical on both sides. When we take out this x, it's gone and we have 1 equals 1. When we took away the x, we never got it. We don't have an x to solve for anymore. That's when we write the words infinite solutions. There's no way to solve the problem because x could be anything. Any number will work and keep the scale balanced because the x could be, there could be anything in that paper bag. It could be 5 coins, 10 coins, 1 billion coins, and the scale would be still balanced. So it has infinite solutions. Here's a few examples. Notice 3x equals 3x, same amount of x on both sides. Next one, 5x minus 7 equals 5x minus 7. That's identical. And the next one, 10 plus x equals x plus 10. Even though they're switched around, it's still identical. Our last weird scenario is the no solution scenario. That's when we have the same amount of the variable on each side, but different amounts of the constant. So I call this the almost identical scenario. Here, in the example above, I've got x plus 1, 1 paper bag plus 1 gold coin, equals x plus 2, 1 paper bag plus 2 gold coins. But if I take away the paper bag, notice it doesn't balance out. The 1 is lighter than the 2. No matter what x is, this right side has 1 extra gold coin than the left. So no matter what I do, I can't solve for x. Here's another example down below. Here I have 3x plus 1 equals 3x minus 7. The x's are the same, but the other number is different. So it will have no solution. There's no way to solve it. So let's practice that briefly. Your decision is it infinite solutions, no solution, or one solution? Go ahead and start with the first problem. You should have decided that there were infinite solutions because it is identical on each side. 3x minus 7 is identical as 3x minus 7. If the sides are the same, you can't figure out what's missing. How about the next one? Distribute first. So you should have distributed here and gotten 10x minus 5, because 5 times minus 1 is a minus 5, equals 10x plus 8. That's going to be no solution here. All right, next. Go ahead and simplify the left-hand side before you start solving it, and then decide, is it infinite, no solution, or one solution? Well, here we have 12x minus 2x to combine, and that gives us 10x plus 9 equals 9x plus 10. Notice the different amount of x's here. That's going to be one solution. There's only one. There is a way to solve that problem. How about our last problem? Looks like a big and ugly one, but all we have to do is answer infinite, no solution, or one solution. So combine your like terms on the left first. you should have combined the 6x and the plus 3x to get 9x minus 19. Okay, go ahead and distribute on the right. You should have gotten 2 times 4 is 8x. 2 times minus 9 is minus 18. And we have 2 more terms here, plus x minus 1. Okay, go ahead and combine like terms on the right. You should have combined the 8x and the plus x to a 9x, and the minus 18 and the minus 1 to combine and make a minus 19. We'll now decide infinite, no solutions, or one solution. You should have decided infinite solutions because the sides are identical. Alright guys, that concludes our little review. That's the whole chapter in a nutshell, and we'll take our test later in the week. Alright, thank you, minds and your hearts, and I hope you have a wonderful afternoon.